Examples of vector quantities. Displacement. If an object moves from point A to point B, its displacement is a vector quantity. The magnitude is the straight line distance between A and B, and the direction is the straight line path from A to B. Velocity. Velocity is a vector quantity because it involves both speed and direction. If an object is moving at 30 meters per second eastward, the velocity vector is 30 ms to the east. Force. Force is a vector quantity that describes a push or pull. In addition to the magnitude, measured in newtons, the direction in which the force is applied is crucial for a complete description. Acceleration. Acceleration is a vector quantity indicating how an object's velocity is changing. It has both magnitude and direction. For example, if a car accelerates at 5 ms/tu north, it experiences an acceleration vector pointing north. Vector operations. Vector addition. When adding vectors, both magnitude and direction must be considered. The parallelogram rule or the triangle rule can be used to determine the resultant vector. Vector subtraction. Subtracting vectors involves adding the negative of the vector being subtracted. It's important to consider the direction when subtracting vectors. Scalar multiplication. Multiplying. A vector by a scalar affects only the magnitude of the vector. The direction remains unchanged if the scalar is positive. If negative, the direction reverses. Dot product. The dot product of two vectors yields a scalar. It is calculated by multiplying the magnitudes of the vectors and the cosine of the angle between them. Cross product. The cross product of two vectors results in a vector that is perpendicular to the plane containing the original vectors. Its magnitude depends on the magnitudes of the original vectors and the sign of the angle between them. Understanding vectors is crucial in physics, as they are used to represent various physical quantities, including motion, forces, and other interactions. The ability to manipulate and analyze vectors is fundamental to solving problems in classical mechanics and many other branches of physics.